Welcome back to the course on superconductivity. Today we're going to talk about conductor usage, conductor length, and number of joints. We'll first see a practical superconducting magnet application and the conductor usage, then see the conductor piece length and the number of joints. To finish, we'll see why this is important. This is a typical MRI magnet that you can see in hospitals. These devices contain a superconducting magnet used to create a strong magnetic field on the patient. We'll see how these are made on the next slide. On the left-hand side is the nomenclature of an MRI magnet. The orange parts are superconducting coils, with the main coil generating the magnetic field in the innermost layer. The outer coil can be used either as a correction coil that will increase the field homogeneity or used to cancel out the field outside the device. On the right-hand side, we can see a typical solenoid, which is the main coil shape used in MRI. Winding a superconducting coil means putting superconducting wire around a frame to obtain a predefined shape. There are many types of superconducting wire, but there are two main categories, tapes and wires, that are wound to make a magnet in its final shape. For example, let's consider a solenoid of radius r with n turns. To calculate the total length of conductor to wind, we take the circumference of the solenoid times the number of turns. This length is the conductor usage. Depending on the wire or tape used and the number of turns, one may need to consider the wire thickness. Superconductive wires and tapes are produced with a certain length, so they are sold in spool like the one on the left-hand side. This is the conductor piece length. Taking as an example a magnet that needs 10,000 meters of conductors and the spools produced are 1,000 meters long, we would need 10 spools requiring 9 joints to make the magnet. What we studied today has direct financial consequences. The conductor usage directly impacts the material cost, noting that HTS tapes are usually sold around $80 per kilo amperes meter and LTS around $1 per kilo amperes meter. Also, the number of joint increase the manufacturing cost and may add losses while operating or even some problems during the manufacturing process. To put today's lecture in a nutshell, a good design has good performance, a low conductor usage and a low number of joints. To conclude, by definition, the conductor usage is the length of conductor needed to make a magnet. The conductor piece length is the length of one spool of superconductor. Joints are the parts where two superconducting wire are joined together. These three parameters impact directly the cost of making and operating of the magnets and are consequence of a good or bad design. On a side note, here is a table with some important parameters for today's lecture. We can see that usually LTS wires have a much longer piece length than HTS wires. This one of the problem of HTS at this time.